Assalamualaikum warahmatullahi wabarakatuh. We are Group 3 from class NACDF 2A, and today we will focusing on compound interest and annuity. First, let's introduce our members. The active team working on this project include Hasan, me, and Hakimi. We do want to note that, unfortunately, two of our group members will not be continuing their studies this current semester. We are definitely missing them, but we hope they will come back next semester. With that out of the way, let's get started into understanding about compound interest and annuities. Hello everyone, let's dive straight into question 1. We are looking at a scenario involving Nina, who owns a rare painting currently valued at 250,000 ringgit. She is faced with a financial decision and has two options. Option 1 is to sell the painting right now, invest the money at an interest rate of 4.2%, compounded semi-annually for 6 years. Option 2 is to simply keep the painting and sell it after 6 years for a guaranteed 300,000 ringgit. We need to find out which option gives Nina the best financial return. Let's evaluate option 1 using the compound interest formula. Our principal P is the current value of the painting, which is 250,000. Our annual rate K is 4.2%. And since it is compounded semi-annually, our M is 2. The investment period T is 6 years. First, we find our periodic interest rate I by dividing 4.2% by 2, giving us 0.021. Next, we calculate the total number of compounding periods N by multiplying 2 by 6 years, which equals 12 periods. Now we plug this into our future value formula. Substituting our values, we multiply 250,000 by 1.021 to the power of 12. Using our standard 5 decimal place, we get 1.28324. We find that the accumulated amount after 6 years is exactly 320,810 ringgit. Now, for the final comparison, option 1 yields 320,810 ringgit, while option 2 only yields 300,000 ringgit. Therefore, option 1 provides Nina with a significantly better financial return, giving her an extra 20,810 ringgit in profit. Let's look at question 2. We will set our focal date at the very end of the 8-year timeline, where Sarah wants her balance to be exactly 6,500 ringgit. The account pays 6.25% compounded every 4 months. That means it compounds 3 times a year, giving us a periodic rate of 0.02083 when using 5 decimal precision. To find the missing second deposit, P2, we push all her money to year 8. Her first deposit of 2,000 ringgit sits in the account for the full 8 years, which is 24 total periods. Multiplying by our growth factor of 1.64014, this initial money grows to 3,280 ringgit and 28 cents. Sarah makes a second deposit, P2, at year 5. It only grows for the remaining 3 years or 9 periods. This attaches a future value factor of 1.20387 to P2. We simply subtract the first deposit's growth from our target, leaving 3,290 ringgit and 70 cents. Dividing that by our P2 factor gives us our final answer. Sarah's second deposit must be 2,674 ringgit and 47 cents.
Answer for question 3. K represents the nominal annual interest rate. Compounded quarterly, since it's divided by 400 equals 4 times 100. Over 20 quarters, 5 years, the annual rate needed to grow 15,000 into 9,711 is 5.5% per year. Answer for question 3C. Our final RM 21,986 and 10 cents. RM 15,000 was the original amount invest, the principal, and the remaining RM 6,986 and 10 cents is the interest earned from compounded at 5.5% per year, compounded quarterly over 7 years. Answer for 3B. Using the compound interest formula with the annual rate of 5.5%, 0.05500 compounded quarterly over 28 quarters. A equals to 15,000, open bracket 1 plus 0.05500 divided by 4, close bracket, raised to the power 28. Step 1. Divide 0.05500 by 4 equals to 0.01375. So A equals to 15,000, open bracket 1.01375, close bracket, raised to the power 28. Step 2. Open bracket 1.01375, close bracket, raised to the power 28 equals to 1.46574. Step 3. Multiply to find A. A equals to 15,000 multiply 1.46574. A equals to RM 21,988 and 10 cent. Answer for question 4A. With a loan of RM 621,000 at a monthly interest rate of 0.383%, 4.6% annually, repaid over 360 monthly installment, 30 years, the borrower must pay a fixed amount of RM 3,183 and 80 cents every month to fully pay off the loan by the end of the term. Answer for question 4B. Even though the loan itself was only RM 621,000 over 30 years of monthly payments at 4.6% annual interest, the borrower ends up paying a total of RM 1,146,167 and 37 cents, meaning RM 525,167 and 37 cents of that is a pure interest, almost as much as the original loan amount itself. This illustrates how compounded interest over a long term significantly increases the true cost of borrowing. Answer for question 4C. After making 320 out of 360 monthly payments, with only 40 payments month remaining, the borrower still owes RM 117,887 and 27 cents on the loan. This shows how near the end of the loan term, most of the principal has already paid off and only a relatively small remaining balance is left. Answer for question 4D. If a borrower misses 4 consecutive monthly payments, the amount that they owe isn't simply 4 times RM 3,183 and 80 cents. Because each missed payment continues to accumulate interest the longer it goes unpaid, the total arrears grow to RM 12,856 and 85 cents. Adding the current month's payment that's now also due brings the total amount required to bring the loan current to RM 60,040 and 65 cents. This highlights how missing payments compounds the financial burden over time.
Let's wrap up with question 5. Orchid buys a kitchen island for 38,450 ringgit, paying a 15% down payment that comes out to 5,767 ringgit and 50 cents. Subtracting this from the cash price leaves her with an actual loan balance, our present value A, of 32,682 ringgit and 50 cents. Her monthly installment R is 849 ringgit and 70 cents, with an interest rate of 4.99% compounded monthly. Our periodic rate is 0.00416 using our 5 decimal precision. We need to find the total time and using the present value of an annuity. We plug in our balance, monthly payment and present value. To isolate n, we multiply the balance by 0.00416 and divide by 849 ringgit and 70 cents, giving us 0.16001 on the left side. Rearranging the formula leaves us with 1.00416 to the power of negative n equals 0.83999. By applying natural logarithms to both sides, we bring down the exponent and solve for n. The math gives us 42 months dividing by 12. It will take Orchid exactly 3.5 years to settle balance in full.